Welcome back. Let's talk about the reaction quotient and predicting the direction in which a reaction will proceed. Okay, so what is the reaction quotient? The reaction quotient is given the symbol Q, capital Q. It has the same form as your equilibrium constant does. So products raised to their coefficients and over reactants raised to their coefficients. But the concentration or pressures that you're putting into your Q value are not necessarily at equilibrium. They're just a snapshot of one moment in time. And we are going to be able to use that information to decide whether or not a reaction is actually at equilibrium. So in order to do this, we're going to take our value for Q that we can calculate and we're going to compare it to the equilibrium constant value K. And if they are the same, then you know that the system is at equilibrium. However, if they're not the same, then the system's not at equilibrium. If you recall, since Q is going to be products over reactants, just like K is, then if Q is less than K, that means that at that moment in time, I have more reactants than I would need to have at equilibrium and fewer products. And so if that's the case, in order to reach equilibrium, the reaction needs to use up some of the reactants and make some products. And so we're going to say it's going to proceed toward the product side or shift right. On the other hand, if Q is too large, Q is greater than K, that means that at this moment in time, I have more products than I should have at equilibrium relative to that ratio of products versus reactants. And so in order to get closer to equilibrium, some of those products are going to get used up and they're going to get turned into reactants. And so we say that this reaction will proceed toward the reactants in the ultimate goal of achieving equilibrium. Let's take a look at one example where we do this. In this example, I have 0.249 moles of nitrogen, I've got hydrogen, and I've got some ammonia, and they're all in a 3.5 liter flask. And the question is this reaction at equilibrium? And I know for that reaction, Kc is 1.2. So if you remember what Q is going to be the concentration of the NH3, and I know I'm using concentration, not pressures, because I'm given moles and liters, and I'm also given a Kc value over the concentration of N2 and the concentration of hydrogen cubed. In order to calculate a value for Q, I have to have molarity, and so we're going to need to turn the moles of nitrogen, hydrogen, and ammonia into molarity. Once I have all of those molarities, I'm just going to plug them into the Q expression to get a number for Q. And I get 0.613. That is not equal to 1.2. And so since it's not the same, it's not at equilibrium, and I see that Q is less than K, which means I'm going to have too much of the nitrogen and the hydrogen, too much of the reactants in the denominator. And so in order for this reaction to move toward equilibrium, some of those reactants are going to need to form products. And so this reaction will proceed toward the product side on its quest to achieve equilibrium.